I'm sorry, I'm a few minutes late today. Okay. Uh, Welcome everyone. Can you hear me? Okay.
Yes,
I can hear you.
Yes. Thank you. Today the agenda is to start with a brief update on the data collection, and then Nicola Rodriguez from Karim OS Laboratory will share some of his latest analysis on the SLAP2 data. Anything else everyone wants to bring up?
Jerome, I just wanted to say, after my talk, I've been in touch a bit with Jeff over
Yes.
email, and he has created the forum. So I'm going to also have a meeting with him. He said he won't be able to make it today, but yeah, I'm going to read his comments and apply there, and he and I are also going to meet separately. Yeah, so hopefully we're trying to see, like, because they kind of had the opposite results to us, and
Yeah.
that's all. But I will
Any
comment on the GitHub thing.
That's wonderful. Yeah. Any results of your discussion? It would be great to hear. I'm curious
Sure. Yeah.
to get
Yeah.
your
I
share
I
opinion.
guess sure. I guess I will update it on the GitHub for where he
That's great.
started. Thanks.
Okay, so in terms of data collection, we are starting real nice work for NeuroPixel data this week. We anticipate some of the first NeuroPixel recording to come out in early November, so the first week of November. Last week with Carter Peen and Ryan in the NeuroPixel team, we did some debugging of the data packaging to make sure that we can package this quickly. I'm hopeful that this will be fast. So that means we'll likely have recordings from NeuroPixel data in early November with the sensory motor design as well as zebra and TRPE and receptor fields. So I will be really curious to see the analysis of his data by the group. Any questions on this? Okay, so maybe Nicholas, do you want to take the lead in presenting your analysis? Can you hear me?
Can you hear me?
Yes.
Yeah. So I'm having some trouble with my camera today, so my camera will be off.
That's okay.
Can you see the screen?
We can't see the screen. It's a bit vertical band. I'm not sure it's because the ratio of your screen, but if you
Uh,
if you go
let's
full
see.
screen, maybe that will fix it. Yeah. Yes, that's better.
Okay. So for this presentation, I'm going to be comparing my PCA analysis, a PCA analysis I conducted a little while ago on an older SLAP2 data set, and I'm going to be comparing that with respect to its methodology to Jesse's more recent PCA analysis. I haven't yet had the chance to reapply this analysis to the most recent data sets, but that's something that I intend to do. So
Nicholas,
this is
could you go full screen? I think that will help us read presentation mode.
I see. Okay, let me. Here, I will.
And Jessie told me that she could not make it today, but I'm sure she will watch the recording and provide comments to Nicholas.
Okay, great. So do you see the screen now in presentation mode?
Well, I just don't. I just see the PowerPoint view, but not the whole slide. Only one slide.
So I'll just share my entire window in that case. My entire screen, that is. Is that better?
It's still PowerPoint. The whole. Oh, that's better. Now we see your slide.
Okay.
Thank
So
you.
this is just an overview of the pre-processing pipeline that I had implemented, where what I did was for the pre-block and the post-block, I computed orientation tuning vectors. This is the pre-processing pipeline I implemented to ensure that the orientation tuning vectors capture the relative preference each ROI has for different orientations, rather than say whether or not an ROI really responds a lot to a particular preference. So really what I'm capturing here is the relative difference with respect to the pre-block and with respect to the post-block, rather than the absolute difference in orientation preference with respect to these ROIs. So I think that's an important point. Here are just for the purposes of visualizations, here are just a few radar plots that capture the pre to post difference in orientation tuning preferences with respect to, in this case, DMD2. I also generated similar figures for DMD1, and that can be found on the GitHub discussion thread. So from what I've observed from looking at the figures, and this will be evident in some of the figures that will follow this slide, is that the ROI's tuning curves are changing at multiple orientations when you compare the pre to the post. So to answer a few of these questions here, that is, of the angles that change, which orientations are changing? Do the ROIs are they just, when they're changing orientation preferences, are they just changing their orientation preference for a single angle? To address that, I built a cross covariance matrix. Now, what that is that it's comparing it's a cross covariance with respect to the tuning vectors for each ROI for the pre-block and the post-block. So what the cross covariance matrix is describing is how these orientation tuning vectors are changing between the pre and the post-block. So my idea is that if you were to apply then PCA to this, what you would capture then, or at least what the PCE components would capture, are the dominant modes in which these orientation preferences are changing between the pre and the post block. So this is my summary of the differences in methodology between Jesse's approach and my approach. The main difference seems to be that Jesse's approach relies on computing the PCA from an input matrix that consists of stimulus presentations and the activity of each ROI for the time bin around that stimulus presentation. So in effect, when you're looking at PCA, she's computing a covariance from this. And what the PC components would then be capturing are how it is that the absolute activity of these different ROIs are changing over time for each stimulus presentation. On the other hand, like I've mentioned earlier, what my PCA analysis is doing is it's looking at how it is that orientation tunings are changing from the pre and the post block. So in a way, Jesse's approach is capturing, the PC components will probably be capturing more instantaneous differences in activity across the ROIs, while my approach is capturing changes that happen at a different temporal scale, not an instantaneous temporal scale, but the temporal scale of blocks. Since the orientation tuning vectors I'm computing for the pre and the post blocks are computed from the activity of, say, a specific ROI across the entire pre-block or the entire post-block. So the orientation tuning vector I compute for each ROI is a summary, in effect, of that ROI's orientation tuning preferences during that block. So the temporal scale is different between Jesse's approach and my approach, is what I'd like to say. So these are the PC loadings of the PC components I generated for my analysis. It'll be a lot easier to interpret what these mean in a later plot that I show, where I compare the pre and the post orientation tuning differences while using these PC components to perform a rank 2 reconstruction of that data. Because as you can see here, in, say, PC1, one of the dominant angles in which orientation tuning preferences have changed across the ROIs is the 90-degree orientation, which would be the oddball. So from this very I think some of the observations I'm making now will be more evident in, again, like the future plot that I'm going to show after this slide. But it seems like our analyses seem to be suggesting similar things. That it seems like that orientation is well, the oddball block is modulating the activity of the ROIs. I believe that Jesse's analysis seems to suggest that as well. Although I think that my analysis certainly, I think, complements her, and that it makes it a little bit more evident. But I'll skip over these plots. These are just an example of this is just a rank 1 reconstruction of the cross-covariance matrices to highlight how it is that orientation tuning preferences are changing between the pre and the post block. But this is the plot that I do want to show, where if you look here in, say, DMD1, I think it's very evident here that the oddball block is modulating the orientation tuning preference of the RYs. Each of these dots corresponds to a different ROI. So I think that, and this is the same for here. So this is highlighting something similar for the 0 degree, where it's highlighting, say for instance, a specific ROI had a very strong preference for the 90-degree stimulus in the pre-block. What this plot is showing is that its preference is much less for the standard stimulus, the 0 degree, in the post block, and the other plots can be interpreted in a similar way. And this is just a different view where we're looking at, say, if looking at the orientation tuning preferences of these RYs with respect to the 0 degree, and how it is that that's different in the post block. So say for instance, I had a very high preference for the 0 degree, it would have a high preference for the 0 degree in the post block. If it had a high preference for the 0 degree in the pre-block, it has a very low preference for it in the post block, and so on. So I think that our analyses are similar and complementary, and the main difference is mainly in temporal scale, where Jesse's analysis is looking at instantaneous changes in activity, and what the PC components that she computed would be capturing those instantaneous differences, regardless of block or across all blocks. But my analysis is acting on the block timescale and is relying on a cross-covariance matrix computed from tuning vectors that are the summary of the ROI's orientation tuning preferences for throughout an entire block. So the timescale is more at the block level. I think what's missing from my analysis and Jesse's analysis is the role of space. I think that neither of us have really delved into the spatial, how it is that the spatial arrangement of the ROIs are impacting any of this. So I think that would be a good next step for future analysis, to incorporate space into this PCA analysis.
May I make a comment?
Yes.
I think another difference that I see in Jesse's analysis is that she doesn't, I don't think she doesn't assume any tuning, because the way it's structured is the array, you take the temporal trace of each ROI against grading presentation timing, and then it's concatenated across all the ROIs. So, and then PCAs run on top. So then the top PCs can be purely based on whether they're locked to the repeated presentations of a stimulus. So it's not assuming any orientation tuning per se.
Yes. Yeah.
So I think I concur with your point that those are complementary, and so you would probably want to do. I guess you would want to do the Jesse's approach first, and then your second to dive deeper into how the orientation tuning changes specifically. Is that
That makes
fair?
sense. Yeah. That makes sense. Yeah, I would yeah, I suppose Jesse's analysis is, it's somewhat, of course, like her analysis is still like in its beginning stages, so she hasn't really looked at orientation with respect to these PC scores that
That's
she
right.
generated.
That's right.
I think it's, what do you think of the assumption? What do you think is the impact of making that assumption? Do you think it's a appropriate assumption to assume that?
I think I mean, orientation tuning has been shown in V1, so I think it's a valid basis vector to analyze the data against. I just feel like both approach are valuable because I think Jesse will be characterizing how the network main modes evolve over the course of the session. And then you could dive into specific orientation tuning because you're sort of feature engineering a lot more.
That is true. Yeah. Yes.
And I think
Yeah, that
both,
makes
I think
sense.
the real interest of this analysis, in my view, is to dive into learning, right? See how those modes of activity changes over the course of the session. And so in my mind, that's where this is going to be insightful.
From what I understand, I think that ideally, these PC components that Jesse is extracting, they would capture an instantaneous mode of variation of change in the data that would be toward, say, either a preference for the 45-degree or a preference for the 0-degree. They would be somehow related to the orientation, somehow related to the oddball block. So I suppose like the question is, when we're agnostic to whether or not they're orientation tuning vectors, we're not performing this feature engineering. With Jesse's approach, is it evident in, say, any one of these PC components that these ROIs are preferring one orientation over another? But I think also, yeah, I would agree that, yeah, I think, yeah, I think I would agree that the two approaches are complementary. I do think we need to delve into space somewhat more, however, to take advantage of the fact that we have spatial positions for the ROIs. And that would take the analysis further than either what I've done or what Jesse has done.
That's right.
So I have a few thoughts on where this could be going, if that's interesting.
Yes.
So in my as a vision scientist, I think many years ago this would have already been pretty striking, because the assumption was that orientation tuning is a V1 property. And the signals we're looking at here are the inputs to V1. So I just did a quick literature search, but in the mouse, we already know now that in the orientation tuning starts in the retina, and you can find it in the LGN. So by itself, it seems less surprising, even though we're still learning that it seems that then the plasticity that you're seeing could also be attributed to the retina or the LGN. So that's already interesting. But I'm wondering if we extend this to the data that we have, for example, interneurons versus pyramidal cells for the SLAP2, we have some interneurons as well, to repeat the analysis and see if they behave the same way. In other words, if the inputs to the interneurons might not. That would be interesting to see a discrepancy. And the other one, to compare that to the not spiking out, but the calcium imaging done at the same time. And I know we only get the first 20 minutes, so it may not be feasible, but to compare inputs to outputs for the V1 neurons and how far this shift in inputs might actually sway its output. The other thing I want to say real quick, same comment I had for Jesse, it can be worth to not treat the principal components as a black box, but to actually look what they look like. So I always recommend plotting the principal components. What is their shape? Because that can be informative for your load, right? So when you see the shape and then you see the load, it makes more sense rather than never looking at the components, not knowing what they actually are.
Yeah, I agree. I think these plots are nice in that I am reconstructing the cross-covariance matrix using a rank reconstruction. So say using this PC component here. And I'm reconstructing the cross-covariance matrices using each PC component independently. And that can be helpful since here we see when the pre-orientation degree is, when the orientation preference for the 90 degree is very small, it tends to be very big in the post block. So this is also a helpful visual that could complement also the PC loading. So I am curious about if you could explain a little bit more detail your first point, and why it might be interesting to say look at the impact of interneurons on changes in orientation preference.
Well, if we would find something there, it would be big. I'm not sure we will. I think the null hypothesis is that you should find the same thing. But if there would be a difference, that would be a big finding. Because again, I think by itself now the finding, you could say, okay, so now we already know that it's orientation tuning before V1. And here you show that that can be shifted by showing a stimulus many times. So there's some adaptation going on and it shifts the orientation tuning. But and but could we find something bigger than that? Is what I'm saying.
I see.
May I add a comment to this? If you guys can hear me?
Yes. Yes.
So at this stage, I think addressing the questions that have been raised relies primarily on the ability to put together a model, a mathematical model, for example, of some sort, that would combine both the feed-forward adaptation throughout the visual pathway in response to showing the same input multiple times versus what one would think would be the feedback, presumably coming from some higher order area that could be interpreted as prediction. I think without separating the two, we are going to always interpret this analysis as, oh, there's something changing, but we really do not understand what is the source of that change. Where is it coming from? And I think the spatial analysis, where we now can take subsets of inputs, subsets of ROIs on the basis of their spatial location, whether they are closer to the cell body, the soma, whether they are on the apical side of the dendritic tree. I think that can help us tease apart those two possibilities of where the source of the adaptation is coming from. So I think that's the next step that we intend to do.
I'm agreeing with Karim. Just want to bounce on both points that were raised. You have weights for the PCs, right, that are distributed across ROIs. Is that right, Nicholas?
Oh, yes. If you look at the slide currently, you'll see these weights. I also have it for DMD2 as well.
But so the
Oh,
weights
for
are
across ROIs is what you're saying. I see.
the weights are distributed across orientations or across ROIs or both?
Across orientations.
Because I
So
think
in the
yeah. So that means you average the. How is that possible? 'Cause so you're creating for each ROI, you're creating a new PC, a new set of PCs.
no. For what we're doing is we're basically what we're doing is we're averaging in a way. We're averaging through orientation differences from the pre to the post block. So this is not specific to ROIs. This is across all the ROIs in DMD1. What are the dominant modes of change we're seeing?
I see. So because you could run PCA, so it has to combine ROI. It's a little more similar to what Jesse is doing, but one could run PCA or cross ROI to create a combined set of ROI that capture this change of orientations between the two blocks. And then the weights will indicate how the mode of change is distributed. Across the ROI. Do you understand what I mean? Or?
Not quite.
So let's say you measure the orientation vector of each ROI. And then you subtract the pre from the post for each ROI. So you get a delta ROI change for each ROI. So it's a feature vector that show all of the orientation changes for every ROI. And then you run PCA where the covariance matrix is measuring for each ROI the change pre and post. And
Yes.
then you combine the covariance is across ROI. So you're trying to combine ROI that have the same or similar change between the pre and the post. So you get a weight vector that is weighting ROI into one. So you're getting into space.
I see. So what you're saying is that yeah, we have this matrix consisting of differences in the orientation tuning vectors for each ROI. So say the difference between ROI1 and ROI1 with respect to the pre and post block. And then we're computing, okay, what differences tend to be similar, right? Like what ROIs are experiencing similar differences.
That's right. So then you're going to create a
so
new.
that would be kind of like a k-means, some kind of similarity metric could be used.
Yeah, in some ways, PCA is doing that for you, yeah. Because the first mode will be the major mode of variance across the ROI, and then you can analyze the weights and see them in space.
Oh yeah. I think I can. So you're saying that you can visualize then? Yeah, I think that can be done in this case as well, where I would just take these PC components and I'll compute the score for each ROI. I suppose then, though, in the case of say PC1, if you were to compute the score, it wouldn't be clear. Well, it would, if it's positive, the ROI has come to favor these degrees. If it's If it's a negative, it comes to favor these other degrees. Hold on, my headphones are not quite working. Can you hear me?
Yeah, it was clear to me, but now it's. Can you speak again? Oh. Hello?
Oh, hello. Yes,
Yeah.
I can hear you. Yeah.
The sound is different, but it's clear.
Okay. So yeah, I think that yeah, what you approach can be implemented. Yeah. That you're taking these whether it's, say, for instance, taking these PC loadings and then computing a score for each ROI and then be able to run spatial analysis, some kind of spatial analysis on that, or an approach like what you discussed, which I imagine I mean, I suppose the kind of I would have to kind of think a little bit more about the technical details. But I think either way, I think the door is open for spatial analysis.
Because I think, as Alex mentioned, if you see the dominant mode of change is distributed on the proximal dendrite, right? But we'll be favoring that what is changing is the input, perhaps from the LGN, but could also be local recurrence, or if it's the apical dendrite, that would be, like, as Kareem said, the feedback.
Yeah, I think it would be good to form, I mean, to my mind, it seems like it would be good to form some kind of idea of what we expect to happen. And it could be that a mathematical model could help with that. And possibly what we could do is we could run a similar analysis, like the kind of PCA we're doing here, on the output of that mathematical model, which I assume would be able to simulate data. And we can form some expectation of what would happen given two opposing hypotheses. One hypothesis saying apical dendrites do this, another hypothesis saying that they don't do that. And then once we form some expectation, then we can reapply that analysis to the empirical data to validate the hypothesis or determine which we have more evidence for. Because it seems like I do feel like we are kind of, or at least I'm kind of going at this somewhat blind. Like, we're looking for differences, but what do they mean for, say, predictive coding?
Yeah, you're likely missing the rest of the network to get more insight. I think that's why we're doing this multimodal experiments. But I think modeling is valuable. Eventually, that could be constrained with the multimodal data. Because here you only have one cell input. But say when you have the NeuroPixel data, where now we have the local network or the calcium data with the inhibitory neurons, I think that would allow to better constrain it.
Yeah, is that when do you expect to have a data set like that available?
NeuroPixel is, as I said, early November we'll start to record. And calcium later in the year.
So speaking of that, the NeuroPixels, do we know where each electrode subset landed?
So we went by the plan that we discussed a few weeks ago, right? V1 is a number of motor areas in the prefrontal cortex, as well as the LGN. So, for instance, to speak about Alex point, we'll record the LGN. So that would, I think that would be highly complementary to the SLAP data. Yeah.
Yeah. So in this case, would we be able to know what, for example, channels, 1 to 100 are in specific area versus all the rest of the array, or is that going to be something that we have to infer from the actual recordings?
I hate to put, but Severin, do you want to speak to that, or can you hear me? Maybe not.
Yeah, no, I hear you. So yes, we will be able. So we have a software that helps us to determine the limits of each area. So you will receive a file saying from channel 1 to channel 100, it's in V1, or channel 200 to 250 is in LGN, or something like that.
Okay, that's exactly my question. Okay, great. Would you have some time offline, to help me a little bit understand how to plan for a NeuroPixels experiment, given a specific set of areas that I want to target? Because we have this, started under a different project, but I looked at the website, but it's a little bit hard for me to understand what's going on.
Can you provide a little more context? So you're interested in our expertise in targeting, or?
Yeah. Basically, how do you, given a set of areas that you want to target with the NeuroPixel, how do you go about planning for the penetration spot
yeah.
and the trajectory and all of that stuff? Because we've done it, but we haven't done it with the same approach that you guys are following. So, in an effort to standardize things a little bit better.
That's fine. I mean, you can post a post on the forum or reach out,
Okay.
and then we can discuss.
All right. Yeah.
Yeah.
Thanks.
Yes. Nicholas, was there other thing you wanted to discuss, or?
Oh no, that would be it. I don't have
Okay.
any.
So I think we have started to push the newer data from SLAP2 on Dandy. Carter,
Yeah, I was about to make that announcement. So I was attempting to get it up before this morning, but there were some challenges. I expect to have like 5 new files on Dandy today, perhaps tomorrow. So keep an eye out for a post I'll make on the forum to alert you guys that the new files will be ready.
Yep. Okay. So I think it would be great if we can continue to work with you, Nicholas and Jesse, to finalize the spatial analysis on these newer files and the older files as well. Anybody else has thoughts they want to raise today?
I think I'm good. Thanks.
Okay. Thanks everyone. I think we covered what we wanted to cover today, and I'm looking forward to where the analysis are going. Thank you.